After a successful journey to Earth, the alien rabbits of Kepler 22b want to settle down on the planet. Unfortunately, the Galactic Code explicitly states that they are not allowed to settle where other intelligent life can be found. To determine whether humans qualify as intelligent life, the rabbits abduct you and begin to experiment on you. They give you the equation f of x equals cosh of x and ask you to approximate its value at x is equal to -2. If your approximation is not accurate to at least 3 decimal places, humans will not be considered intelligent life and the rabbits will begin the invasion. They provide you with a pencil and paper and a simple calculator which can do only elementary operations. Estimate the value of f of x equals cosh of x at x is equal to -2 using a power series. Prove that the estimate is accurate to at least 3 decimal places. So we've been asked to estimate the value of cosh of -2. In order to do that, we're first going to expand cosh of x into a power series, and then we're going to figure out what the remainder is so we can know how many terms we need to use, and then we're going to plug in -2. So the first step here, we're going to realize that cosh of x is equal to e to the x plus e to the -x over 2. That's just the definition of cosh of x. We're going to multiply both sides by 2, and we'll find that 2 cosh of x is equal to e to the x plus e to the -x. And we can work with e to the x. They're very easy to expand into a series. Because every derivative of e to the x is the same, and we're evaluating it at 0, as long as we make this a Maclaurin series, this becomes very easy. And the Taylor series, or the series expansion, goes from 0 to infinity of x to the n over n factorial. And then for e to the -x, all we're doing is plugging in -x where x is. It's as simple as that. And so it becomes the series from 0 to infinity of -x to the n over n factorial. These are the same series, it's just this one's alternating. We can look at them as a telescoping series and cancel some terms out. And so let's do just that. Our first series, e to the x, starts as x to the 0 over 0 factorial, and then x to the 1 over 1 factorial, and keeps going in that pattern, just like that. Let's stop at here, 3 factorial. It's plus ... because that's going to keep on going forever. The series expansion for e to the -x, we're going to add that. I'll put it right below so we can see, but we're still just adding it. X to the 0 over 0 factorial. This is positive because when n is 0, the -1 is just a positive 1. But then when n is 1, the -1 is sort of gets to shine through. And so we get negative x to the 1 over 1 factorial. And then we go back to positive x squared over 2 factorial, and then back to negative x cubed over 3 factorial, plus minus ... forever. And so these first 2 terms, we can just write that as 2 times, this whole thing is equal to 2 times x to the 0 over 0 factorial. Plus, these next 2 terms cancel out. And so we can move on to the next ones. It is 2, because there's 2 of them, times x squared over 2 factorial. And then the next terms cancel out. And we can probably already see a pattern here. The next one is 2 times x to the 4 over 4 factorial. And so on and so forth. And so before we turn this into a series, let's remember that this is equal to 2 cosh of x. So we divide both sides by 2. And these 2 2's cancel out. And so we know that cosh of x is equal to the series going from 0 to infinity of our x starts at 0, and then it goes to 2, it goes to 4. So it's going up by 2 every time. So it's x to the 2n divided by, the factorial also goes up by 2 every single time. So it's divided by 2n factorial. So now that we know the expansion for cosh of x, and that's written right up here, we can figure out how many terms we need to take in order to prove that our estimate is accurate enough. And luckily there's a theorem for that. The remainder of the nth Taylor polynomial of x is less than or equal to the n plus 1th derivative of c, with c being whatever value maximizes that derivative on the interval, times x minus a to the n plus 1 over n plus 1 factorial. And finding what the n plus 1 derivative is can be very tricky. luckily for us, there's something special about cosh of x that we can take advantage of. So if our function f of x is cosh of x, then the first derivative of cosh of x is sinh of x. And we can prove that by looking over here. We take the derivative of this whole thing. The e to the x stays the same, the 1/2 stays the same, and it's just e to the negative x. When you multiply that, there's a chain rule, and -1 multiplies up and makes that negative. And e to the x minus e to the negative x over 2 is the definition of sinh of x. So we know the derivative of cosh of x is sinh of x. And the second derivative of cosh of x is back to cosh of x, actually. Because, again, when we take the next derivative, that negative goes and turns the negative back into a positive, and we're back to cosh of x. And unlike with sine and cosine, it doesn't ever get negative. So we don't have to do it 4 times, we can just do it twice. And so any even derivative of cosh of x is cosh of x. And to get an even derivative, n plus 1 needs to be even, which means n needs to be odd. So we're going to say, assume n is odd. Very useful. So now we know what this is. The value that maximizes it is, unfortunately, cosh of -2. Because our interval is from -2 to 0, because -2 is where we're evaluating, and 0 is where the series is centered. So on that interval, the highest one is -2. And so we don't know what that value is, but at least we can estimate it. So in order to estimate it, we'll see that cosh of -2 is equal to e to the -2 plus e to the -2, which is just e squared, over 2. And so if every single component of this is bigger, then that second whole thing is bigger as well. And so this whole thing is less than, what's bigger than e squared? It's 3 squared, because e is a little less than 3. So 3 squared, and then what's bigger than e to the -2? A value that's smaller than e is going to be bigger, since it's 1 over e. So 2 to the -2, all of that over 2, we know that that is less than that. And this whole value is equal to 37/8, which we'll just round that up to 5. So we'll say this whole thing is less than 5. And that saves us a lot of work later, because we don't need to actually know it, we just need an estimate that's good enough. Now we're ready to go and plug this in. And so we know that the remainder of the nth remainder here is less than or equal to cosh of -2, so we're just going to say 5 times x minus a being 0, because it's a Maclaurin series, to the n plus 1, all over n plus 1 factorial. And unfortunately, there's not really an easy way to figure out what value of n is good enough for us. We can try to graph it. I'll put up a graph of what that looks like on screen, but we can't do that with our little baby calculator. And so instead, we'll just continue taking higher powers of n. Luckily, we only have to take the odd ones. And so we'll just keep going up until we find a good one. Let's just start with 11, because that just feels like a good number. You'll see why. And so the remainder of the 11th Taylor polynomial at -2, because we can plug it in now, is less than, and it can't actually be equal to, because 5 is definitively less than that. And so we're overestimating. Less than 5 times -2 to the 11 plus 1 is 12, all over 12 factorial. And we can crunch those numbers in our little calculator. It's going to take a while, but we can totally do it. And we'll find that that is equal to 0.000042, roughly. And there's more digits, but they don't really matter, because what's important is that our first 3 digits are 0. Since they're 0, we know that there's no accuracy that's going to affect the first 3 digits. And so our estimate is good enough for the aliens. And so this is our final answer, the third part here, is that we need to figure out, going from 0 to 11, what is -2 to the 2n over 2n factorial. So let's write this series out. This whole series is equal to -2 to the, when n is 0, it's just to the 0, over 0 factorial, plus, when n is 1, it's -2 to the 2 over 2 factorial. And then we're going to keep going until we get to -2 to to the 22, because it's 2 times 11, over 22 factorial. And every single one of those we can do on a little calculator. It's going to take a while, but eventually we'll find that that whole thing is approximately equal to 3.762. And there are more digits, they don't matter, because we just proved that these digits are accurate, and that's all the aliens want. So our final answer is cosh of -2 is equal to 3.762.